Hello, good morning, everybody. I would like to describe our special buildings, which is called SGLC buildings. SGLC building stands from Smart and Green Learning Center.
The SGLC buildings is probably the first building in Indonesia that use a seismic device which is called a viscoelastic damper.
As we know that in Yogyakarta, the earthquake is very high, and we have a potential high earthquake occurring in our city. In the building, we have a reinforced concrete frame structure, and we put as many as 102 seismic devices.
This rubber damper have a 40 by 40 centimeter square and 2 centimeter thick. The capacity of the damper is about 40 ton or 400 kilonewton.
This device is very complex because the behavior is not only depend on the displacement, but also depends on the frequency during the earthquake.
It is divided into groups. From the first to the 7th floor, we put 2 sets of seismic device, 3 of them in X direction and another 3 is in Y direction, and another 30 seismic dampers we placed on the 7th floor to 11th floor.
The challenge regarding to the construction of SGLC is related to the preciseness, and the second one is related to the schedule matching, because the damper holder is prepared in Indonesia while the damper itself produced in Japan.
These damper are designed to reduce lateral displacement, so that the interstory drift should be less than 1%. These dampers, if we don't use this damper, so the lateral interstory drift will be up to 2%.
When the earthquake entering our structure, the energy has been reduced, maybe up to 60 or 70%. And that's why the effect of earthquake on our building will be much better.
So we hope that using these dampers, people using this building will be more comfort.
In this case, the earthquake energy will entering our building in full capacity. However, at every floor that we have, it will be reduced by the damper.
This building also equipped with 13 accelerometers. There are 3 axis accelerometers on base or on the ground floor, and there are 2 axes in certain floors, so that we can monitor the lateral displacement at any time. So at certain displacement, these accelerometers can alarm, and hopefully that everybody using this building will be evacuated. Yeah. So more safer for people using these buildings.
We are going to use this seismic device in modeling a structure. Of course, we should make sure that all the parameters that will be used in the model should comply with the real behavior of the device. Therefore, it is important that the device should be tested before we use it in the model and before we use in the real building.
So we have to consider the situation. Related to the preciseness, we have only 2 millimeter tolerance in order to make the damper work properly. And the second one, related to the construction schedule matching, we have to start the construction while the damper is under production, and then pack and ship to Indonesia. So in terms to schedule matching, I have to modify the method, which is we use the dummy damper, which is I use steel plugs in the position of dampers, and then once the damper come to the site, we will release the dummy damper and then replace with the original ones.
There are 2 objectives of testing this device in the laboratory. The first one is we are going to find out the proper parameters to be used in the modeling. And the second one, we need to make sure that the behavior of this device satisfy the code.
So this kind of method is actually really interesting, because we have to check the preciseness of production in Indonesia to match the standard production from the damper production in Japan. The second one, we have to match about the scheduling, how to maintain the progress and the sequence to the arrival of the damper from Japan.
In SNE 1926 in 2019, this device is categorized in chapter 13 about dampers, and it is said in the code that before we use this device, we should carry out laboratory tests to check the behavior of this device, whether it is satisfied or not.
So I think in terms of the use of the damper, this is the 2 aspects that we have to really concern. Number 1 is related to the construction method, preciseness, and then the second one is how to match with the schedule matching for the construction. This is the situation where the construction become more challenging, and we are very thankful to all parties, from the consultant, the producer, and the contractor, to make the construction of damper structures become to the reality. And I would like to promote the use of this kind of damper because this is the very first time application of its kind in Indonesia, and this kind of damper is having big opportunities, not only for new building but also it's very I think good opportunities to implement in the existing building.
Hopefully, when the earthquake is coming and struck our structure will behave better and better. Not only at one earthquake, but it should be at every earthquake that we have in the future.
In order to retrofit or the seismically improve the performance of existing buildings. So we do hope that the use of damper system of its kind, which is made of viscoelastic high rubber damper, is become more. The knowledge become more spread forward to our engineering communities, and then at the time, probably we can use it in more kind of construction, both for new building or for existing building for seismical improvements. Thank you.